Okay, let's get started. As you know, today I promise to take you on a walk through the solar system. So let's start here at the central object of our solar system, the Sun. As you can see, the Sun is about 5 inches in diameter, and that's about the size of a large grapefruit, which is exactly what I've used to represent it here in our model. So I'm going to take two steps, and that will bring me to the planet closest to the Sun, that would be Mercury. Two more steps to Venus, and one steps from Venus to Earth. Let's continue walking three steps from Mars to Mars. That's the current map, but we can visualize. Don't bother writing this down, just stay with me on this. So to go from Mars to Jupiter, we'd have to walk a little over half the length of a football field, so that would put us about the rivalry here in Cavs. And then to get over to Saturn, we'd have to walk around the 75-yard answer, then we'll be at home hole. From Saturn to Uranus, we'll have to walk again as we go on in the journey from the Sun to Saturn. And so it probably be as a student union for Uranus to Neptune will have to walk the same distance again, which would take us all the way to the graduate orbiter tunnels from Neptune to Pluto. And at 125 years, so we'd end up about one third of the mile from this crossing as the entrance to the campus. Okay, that's interesting, but now I want you to think about the orbits of the planets in those locations. Clearly, the first four planets get orbit fairly comfortably in this room, but to include the others, we'd have to occupy an area of more than 6/10 of a mile, which is all the way from College Avenue to Campus Drive. Remember, that's the scale. And red, that's sharpened pencil. Okay. With that in mind, I want you to think about the space. Sure, there are some moons around a few planets and scattering of asteroids and comets, but really there isn't a lot out there in such a vast area. It's pretty empty, and that's what I really want to demonstrate with this exercise. Now, it would really be even more impressive if you could actually make that work, and actually you can if you visit Washington, D.C., where a scale model is set up on the National Mall, starting at the National Air and Space Museum and ending up at the Arts and Industry Museum. I did that a couple of years ago, and it's amazing. Even though I knew the distance intellectually, there's nothing like the experience. Has anybody else done that work? Well, you're right. It's an eye-opener. It took me about 20 minutes to go from the Sun to Pluto because I stopped to read the information at each planet, but when I made the return trip, it was about 10 minutes. Did you take pictures? I didn't, but I didn't think it would have captured it anyway. I think you're right. What impressed me about doing it was to see what was not there. I mean, how much space was between the body in the solar system, and the photograph wouldn't have shown that. So back to our model, here's another thought for you. Now the scale for our model is 1 to 10 billion. Now let's suppose that we want to go to the nearest solar system, the neighbor to our solar system. That would be the Alpha Centauri system, which is a little less than 4.5 light years away. Okay, let's walk into our model. Here we are on the east coast of the United States. So if we want to make it Alpha Centauri, we have to hike all the way around the rest of roughly a distance of 2,700 miles. And that just to cross to make a model of the Milky Way galaxy would require a completely different scale because the surface of the Earth wouldn't be large enough to accommodate a model at the scale of 1 to 10 billion. Now let's stop here for a minute and just to be sure all together on the terms solar system and galaxy. Remember that our solar system is a single star, the Sun, with various bodies orbiting around it, 9 planets and their moons, and asteroids, comets, meteors. But the galaxy has a lot of solar systems, probably 100 billion of them. Okay? This is important because you can be off by almost 100 billion if you get confused by these terms. Not a good idea. Okay, then. Even if we could figure out a different scale, let us make a model of the Milky Way galaxy. Even then, it would be challenging to make 100 billion stars, which is what you would have to do to complete the model. How many would that be exactly? Well, just try to count all the grains of sand on the oral beaches on us. That would be about 100 billion. But of course, you couldn't even count on them in the right time, could you? If you started counting in 1000 BCE, you'll be finishing just about now in Europe. But of course, that assumes that you wouldn't sleep or take any breaks. So what I'm hoping for from this lecture, what do you think I want you to remember? Well, for one thing, enormous distances and the vast emptiness of space. Oh, that's good. I hope that you'll also begin to apprehend the fact that Earth isn't the center of the universe. Our planet also is very beautiful and unique. It's still just one planet, orbiting around just one star and just one galaxy.